So guys, I'm gonna show you a simulation here in order to make you understand what actually the Brownian motion is. Okay. Now, first of all, what is this motion that we are talking about? So always remember guys, every single particle out there have three types of motions present. Okay. One is called the rotational motion, the second one is called the translational motion, and the third one is known as the vibrational motion. So there are three types of motion. So let me show you translational data. Okay. Now guys, translational. I'm gonna write them down. Right now, just listen to this, and right now I am going to pin my video so that all of you can see me. I guess now all of you can see. Okay, focus. So you can see that I am holding on to a water molecule here. Correct, guys? Water is consisting of oxygen and two hydrogen atoms, right? So this is my water molecule. Correct. Now, Abhinav, if you just look into it, what I'm trying to say is, we know that particles, they move from one place to another place, don't we, guys? Right? We know it as diffusion, right, Nandin? Right, Rishikesha? Now, Sarvesh, the point is, there are three types of motions actually that the particles are having. Maimuna, you can lower your hand now. Now, what are the three motions over here, Sankal? One is, they are definitely rotating. That means they're rotating like this. Or they can also rotate like this as well. We don't know how they are rotating exactly, but they can have different axes of rotation. So they are rotating all the time. Along with that, they are vibrating as well. So they are vibrating and rotating together. And with these two motions, Diana, they are also translating. Translating means moving from one place to another place. So this is how the particles are actually moving, right? So these three types of motions that I'm talking about, they combine together to become the kinetic energy of the particle. I guess you have all heard about this term, guys, kinetic energy. This kinetic energy is nothing but, guys, consisting of these three types of motion present in a molecule. And those who have been there with me in the advanced sessions of grade 8, I have shown them a few types of motions. And for the rest of you, I'm going to show you today some few types of motions here. Okay. And guys, I'm going to tell you, today we are going to have a really good time when you'll be having a kind of, you have never really imagined that the molecules are actually moving or actually having that kind of motion in there. I'm going to show you something about that. But for the time being, guys, we are talking about the result of all these motions. So can you understand where we stand over here? We are not talking about the reason right now. We are keeping it aside for the time being. We are moving forward about the results first. After teaching you the results, guys, I'm going to talk about the types of motions which are there. Okay. So now you can see that I'm going to pump in some sort of particles which are there, and I'm gonna heat them a little bit. You can see that the temperature is rising over here in the thermometer up there. So I'm heating it again. So when I'm heating it, guys, what is the actual thing that I'm doing with these particles? I am giving kinetic. Perfect. Now I am increasing the kinetic energy, Keshavi, right? Increasing the kinetic energy means, guys, I am increasing the three kinds of motion that I told you about, right? The three kinds of motion: rotational, vibrational, and translational. I'm increasing that. Because of that, the particles started moving. Right, Arthur? Right, Ayan? Now, have a look, Kavya. Is there any pattern with which they are moving? There isn't any, na? They have no such particular pattern, Abhinav, that which they are moving. They are moving random. They do not have any particular any particular ways, any particular pathway that they are actually following. They're moving whatever the way they want. So let me start all the way again. Let's say I am pumping in a few red particles. Okay. I want you to see them when the temperature is a little high. Right. Now have a look in the situation. You can, I guess, really visualize now that the particles, they're moving randomly from one place to another place. Correct. This random particle movement is known as the Brownian motion. Because, guys, there was a scientist called Robert Brown who actually said this, that the particles do not follow any particular path, guys. Instead, they follow a zigzag motion. And Kasif, this zigzag motion is known as the Brownian motion. Now, I don't know whether you are actually focusing on it or not, but guys, if you are focusing on it enough, then you will be able to see sometimes the particles are colliding with each other. There are some situations. So you can focus on one particle over here for the time being. Let's focus on this particle and see what happens in here for this particle. This is the slowest particle, and there we go. You saw it got hit by another particle here. So you can understand the reason behind the zigzag motion is nothing but this, like they're getting hit by the other particle. That's the major reason behind this zigzag motion which has been generated in the particles in here. This is actually known as the Brownian motion.